Another way to incorporate an ether into a molecule is to start with an alkene and add acid along with an alcohol. So this is kind of analogous to adding acid and water, where you add H and OH across the double bond. Well, if you add acid and an alcohol, what's going to be added here is we're going to add a proton from the acid, and we're going to add the OR group from the alcohol across that double bond. Remember that these reactions where you're adding acid, they are going to involve carbocation formation, and they're going to follow Markovnikov's addition. All right, remember what Markovnikov's addition is. The hydrogen goes on to the side where there's more hydrogen, and in this case, the OR group goes to the more substituted side. For these types of reactions, I always recommend drawing the full reaction mechanism, because that will let you analyze the carbocation and make sure that it doesn't rearrange, or if it does rearrange, it'll allow you to get to the correct product. So think back to this reaction that you learned in Organic 1. The first step, we have our acid from the H2SO4, so we'll just treat that as H+, and the pi bond will come and grab that proton. Now remember that on that double bond, we already have 2 hydrogen right here that were implied. So by Markovnikov's addition, I'm going to put the 3rd hydrogen on this side. So let's just, for now, draw in all these hydrogens on this carbon. HH, we've added our new hydrogen right here. And we've reacted away these pi electrons, but that leaves a void on this carbon. So this carbon right here will have a carbocation. So let's put a positive charge on it. Once you have this intermediate, check to see if it's going to rearrange. In this case, you have a tertiary carbocation. It's not going to rearrange. So now what I can do is use my alcohol as a nucleophile. Remember that oxygen has 2 lone pairs. And I'm going to draw a curved arrow from the oxygen lone pair to the electron deficient carbocation to form a bond. I'm going to draw the new bond in red just to help us keep track of it. We have the O, the ethyl group, and there's still a hydrogen on that oxygen. So it has a positive charge because there's 3 bonds on the oxygen. This CH3, I'm just going to make those 3 hydrogen implied so we don't have to worry about them. We're almost done. The last thing we need to do is get this proton off of the oxygen. So you can be as specific or generic as you want. I just like to use a B with a lone pair just to be generic with it, but you can use anything in the reaction that has a lone pair to do this step. So this base will come and take the proton off of the oxygen. And now when we draw the product, we have the oxygen with its ethyl group. And now that oxygen only has 2 bonds, so it's happy and doesn't have a charge. If you want to draw the byproduct, that's just BH+. So what we see here is an oxygen that's bonded to a carbon and a carbon, so that makes this an ether.